Welcome, ladies and gentlemen, to day 2 of Equations of Hyperbolas. If you haven't gotten your notepad, get out yet. Go and get your notepad, get out. We're going to be doing the examples that are after this in there. These are equations of hyperbolas not centered at 0, 0. They're centered somewhere else. And you do need to remember these things, or I'm going to be referring to them as we go through. So this is the example that's right under that table. You're supposed to find the center, the vertices, the foci, and the asymptote of this hyperbola, which is a lot of stuff. So let's start by finding the center. Luckily, the center on this is pretty easy because it's in the equation. If you look at this format, we got x and y squared stuff up top, which is supposed to be x minus your h value, y minus your k value. Since it's x plus 2, the h value is going to be negative 2. And since this is y minus 5, the k value is 5. So we got our center already. Check. Let's move on to the next thing. We need to get our vertices. Well, to get your vertices, you do need to figure out if it's horizontal or a vertical hyperbola. Since x squared is first, this is it's a horizontal one, which is this stuff. That's important. You don't want to be doing this when it's a horizontal one. So our vertices are at h minus a and h plus a, and then the k value is the same. So we need to find our a value, and then take this center and go right and left of that amount. Luckily, a squared is always under the first one, so a squared is 9, which will mean that a is 3. So our vertices are going to be the center, plus 3 and minus 3 on the x value. So negative 2 plus 3 is going to give you 1. And then negative 2 minus 3 is going to give you negative 5. So yeah, I'm just taking the h of my center and then adding and subtracting the a value to get these 2 points. Next, we need to get our foci. To get the foci, you got to have your c value. And we can't get the c value unless we have a and b. So luckily, this part here is our b squared, which would be 49. So to get b, you just square root it, you get 7. We're going to be using the b value later, so I got that. The c value, to get that, you're going to require your Pythagorean relation, which, again, for hyperbolas is the same as the normal Pythagorean theorem, unlike ellipses. So c squared is a squared plus b squared. So c squared is 9 plus 49, which means c squared is. So c squared is going to be 58. That is not a very nice thing when you square root it. So c is the square root of 58, which you can take your center and then add and subtract root 58, which will give you like negative 2 plus root 58, and then 5, and then negative 2 minus root 58, 5. But those are not, those are the exact values, and I guess we could write that down. But you can also get the decimal approximations. Let's just go ahead and get the decimal approximations for now, but realize they come from these. So do negative 2 plus root 58, and then negative 2 minus root 58, and write them down. Did you do it yet? Just put it in the calculator so you can follow along, participation. Alright, this is what you should have gotten, which is about 5.62, 5, and then negative 9.61, about-ish. Oh, no, 6.2, my bad. Let's change that to 2. I know how to round. So there's that. Now we have our center, our vertices, our foci. The last thing we need to get is the asymptote, which, let's go with, I don't know, green. Green's a good color for an asymptote. So to get your equation of your asymptote, you're going to need this guy here, which is the point-slope form for the equation of a line that goes to a specific point. Basically, we're going to be plugging all the values in and then writing out the 2 different equations from there. And so we got y minus k, which is 5, is equal to, let's see, plus or minus b, which is 7, over a, which is 3, in front of x minus h, which is negative 2, so x plus 2. So basically these two come from just the equation part in there, because we need to go through that point. This is actually two different equations because you got the plus or minus here. So we're going to write out the two different equations. We got y minus 5 is 7/3 of x plus 2. And then we got the other one, which, let's change colors again. Let's do purple. We got y minus 5 is 7/3 of x plus 2. And then you're going to go through simplifying and, adding 5 to both sides. And you'll distribute. Let's go ahead and do the distribution. Oh, I'm missing a part. I forgot. It's plus or minus. So this one's the plus version, this one's the minus version. And you'll go through and simplify it down. So you got, we got plus 5, simplify. We got negative 7/3 x plus negative 7/3 times 2 plus 5. Negative 14/3 plus 5, which that simplifies. I don't want to do that in my head. Go ahead and get a calculator. Negative 14/3 plus 5 gives you something. Oh, it's just a third. Sorry, I did it in my head. Should be a third. And then over here on our other equation, we got y is 7/3 of x plus 14/3 plus 5, which should give you y is 7/3 x plus, let's see, 14 plus 15 is 29/3. All right, we got an asymptote, and we got another asymptote. So we got the asymptotes, we got the foci, we got the vertices, we got the center. We got all the things. There's a lot, huh? There's all sorts of things about hyperbolas and ellipses, and we'll get to parabolas later, that you need to do, and there's just a lot of things that relate to each other. I guess I want those boxes back. But we'll do one more example, and this one's going to be a whole lot easier because you don't have to get 10 different things. That's an exaggeration. The next examples are, we're just supposed to write the equation in standard form for the hyperbola who has these vertices and the conjugate axis length of 8. So since these are the vertices, you can find your center pretty easily by getting the halfway mark between them. Halfway between negative 2 and 8, well, you add those up, you divide by 2, you get 6 divided by 2, which is 3. So you got 3. And then negative 1 and negative 1, halfway between those is negative 1. Convenient that. And since these are vertices, we can also get our A value. The A value is going to be how far it is from this to one of these other ones. Well, from 3 to 8 is just 5, so A is 5. And A squared is 25. If you don't know why I'm getting A squared, you might have forgotten that the equations look like these. We'll need A squared, B squared, and we'll need the center. So really, we have 2 of the 3 bits of information we need to write out our equation. Here, we got center and we got A squared. The other thing we're going to need is B squared. Something that's going to make a difference later is also noticing if this is a horizontal or vertical hyperbola. Since the x's are changing, right, negative 2 and 8, this is going to be a horizontal one, and that's going to be important when we write our equation. That was a bad line. All right, so we have A squared, and then it tells us the conjugate axis length is 8, in case you have missed it. The conjugate axis, words are hard. The length of it is 2 times b. And so this means that 2b is 8, which will mean that b comes out to be 4. b is 4, so b squared is 16. We have b squared, we have a squared, and we have our center, so we can write out our equation. This is a horizontal one, so we're going to be using this one. So x squared goes first, and then y squared will be second. So we got x minus the h value in our center, which is 3. Over a squared is always first on hyperbolas. And then subtract y minus the y value in our center, which is negative, so we're going to turn this to plus. squared, and then it's over b squared, which is 16, equals 1, and voila, you have your equation. So some of these are a lot easier than others. Some of them are outright mess. Some of them are nice and clean and pretty easy. Not all math problems are created equally. Sorry about that.